Hello everyone, this is lesson 1.3 and here we will start introducing the meaning of limits. Basically, what does a limit mean? In simple words, limit is the y that x is trying to approach. What do I mean? For example, at x equals to c. Okay, at x equals to c. What is y over here? Actually, because this is a linear function, and y is obviously in front of me equal to 5, right? If the letters are confusing you, we can use numbers. For example, let's say this function at x equals to 2, y equals to 5, okay? As I approach 2 from the left side, what is happening to y? As I approach 2 from the left side, y is decreasing, and trying to approach 2, right? Remember, we said the limit is always the y. Okay, what will happen when I try to approach this 2 from the right side? For example, 3, 2.5, 2.1. What are the y's changing to? They are increasing and trying to reach 5 as well, right? So here the limit exists, and of course for any linear function there will be a limit, because it's obvious that the left side here, all these x's, if I'm checking the x's over here, all of them, as I come closer and closer to c from the left side, or to 2 from the left side, I'm trying to approach 5. And these, as I come closer and closer to C from the right side, I'm trying to reach L. It's usually abbreviated with C and L. And how do we read that? We read that the limit as x approaches C equals to L. This arrow means as x approaches C of f of x, the limit here exists, and the answer is L. So if I want to write it using the numbers that I just made up over here, the limit, for example, of as x approaches, the numbers that I made, because we in real questions we're not going to use C and L, as x approaches 2 of f of x, whatever the f of x is, whatever 2x, 3x, any function, but it has to be a function, okay? The limit as x approaches 2 of f of x is equal to what? The number that I just made is 5. It can be any number according to the function. According to the function, substituting the 2, we get an answer. Okay, so here the definition in words, it says if the value of f of x approaches a unique value L as x approaches C, from the left side and from the right side, from each side, then the limit of f of x as x approaches C, the limit of f of x as x approaches C is L. In symbols, we write it, the limit as x approaches C of f of x equals to L, which is read the limit of f of x as x approaches C is L. Okay? So what if the limit is not the same from, because we said over here that it has to be the same from each side. Let's say I have a graph over here and my pieces, for example, a piece looks like this, okay, at number 2, for example, and I have another, let's say over here, another part of the graph, and here it goes. What do you think about the limit now as x approaches 2? As x approaches 2, what is the limit? Okay, let me write numbers for you. For example, let's say this is 4 and this is 6. Open your eyes and think with me. Is the limit as I try to approach 2 from the left side equal to the limit as I try to approach 2 from the right side? Obviously no. Why? From the left side here is 2, okay? From the left side here are the x's. And this x and the next x, these are the answers of the left side. What are they trying to approach? Obviously, they're trying to approach 4. So the limit of the left side is 4, right? Let's check the right side. Are the right side people also trying to approach 4? Here is the right of number 2. It's trying to approach Looks like it's trying to approach another number, right? And here, very, very close to 2, let's assume it's 2.01 or something. What is it trying to approach? And we will try this using tables. It's trying to approach 4. Now, will I say the limit as x approaches 2 of f of x equals to 4 or equals to 6? What shall I write? I have two answers. The left side is equal to 4 and the right side is equal to 6. What shall I do? Basically, I will say the limit does not exist. The limit over here in this case, it does not exist. Why? Because we said that the left side and the right side must equal to each other. And we will try tables and prove, for example, for this question, the table for 5, the table will prove that the left side and the right side, for the original one that I said, the table will prove that the right side and the left side are trying to approach 5. But this table will show me that the left side will try to approach 4, while the right side will try to approach 6 when we substitute in f of x of this function. And of course, this is a piecewise function. In this part, we have the concept summary about continuity test. A function f of x is continuous at x equals to c if it satisfies the following conditions. What are the conditions? We have 3 conditions we have to test to know if the function is continuous at this x or no, which we use c for it. First of all, before I list for you the tests, I would have always to start by using my brain and thinking, because obviously continuous functions, sometimes you will really know that it's continuous without doing all these steps. Let's say I have a function f of x equals to x minus 5. What have you noticed about the domain of this function? Or which type of function is this? Isn't this a linear function? Isn't this continuous everywhere? Like, when will it give me an error? When will I have an x that I cannot substitute in this function? Okay, I know this function and I know it's continuous at every x, and I know it's continuous at x equals to 5, so my answer is that f of x is continuous at x equals to c. Or here, I'm going to use x equals to 5. How will the question come to you? The question will come like this. F of x equals to something, like x minus 5, for example. Is it continuous or no at x equals to 5? They will have to tell you at which x we are talking about. Okay, what is the first question? F of x is defined at c, so my c here is 5. So another way of saying it is f of 5. Does f of 5 exist? Can I substitute f of 5? Yeah, what's the problem? I can substitute f of 5. I will not stop at this step because sometimes it will be defined like the removable discontinuity, but then the next step you will find that the limit does not exist. First, do the 3 tests if you're not very, very sure, okay? F of 5 is equal to what? F of 5, 5 minus 5 is equal to 0. So I passed the first test and the function is continuous, or the f of 5 exists, okay? This was the first step. The second test is f of x approaches the same value from either side of c, that is as x approaches c, f of x exists or no. What is my c in this question? I used 5, right? And what is my f of x over here? The question said it's x minus 5. So basically they're asking me about the limit. Does the limit reach the same number from the left side and the right side of c? Here I used c as 5 in this question, okay? So the questions will come exactly like this. You will draw a table, of course, using a ruler, unlike mine. So I will place 5 in the middle. This is the number that they told me about. This is the c. And I'm reminding you again, the limit is the y, okay? So 5. 5 is equal to 0. How can I know the numbers that are very, very close to the left side of 5? Okay, I can actually not 5. I can, not 5. Of course, less than 5, I can use 4.99999, whatever you like, okay? The closer, the better, to make sure that the answer is right. So we're going to try 4.999. Where do I substitute 4.999? I will substitute it in my function, and this is my function. What will the answer be? The answer will obviously be negative, for example, 0.001. 001. If you try another number that's like, for example, 4.99, okay, you are going to find the answer as, but I already know that this is a continuous function. I'm just doing the steps. From the beginning, we knew that this is a continuous function because we know it. 0.001. Fine. What does when I come closer and closer to 5 from the left side, looks like the numbers are decreasing and decreasing and trying to approach 0. Because next is negative 0.00001 and then negative 0.00001 and so on. So I'm trying to approach 0. I want some numbers more than 5, but directly more than 5. We're going to use 5, for example, 0.001. And let's go a little bit far, so 5.01. And maybe next 5.1, okay? 5.001, where will you substitute it? You will substitute it in this x. Minus 5, you're going to get 0. Are you getting what I'm doing? 0.001. And here I'm going to get 0.1, for example, 0.01, I'm sorry. And next, if I use 5.1, I'm going to get 0.1. As I come from the numbers that are right of 5 and get closer to 5, these numbers look like they're getting smaller and smaller and trying to reach 0. So what do I write now? Yes, the limit as x approaches 5, is equal to what? Is equal to 0. From the left and from the right. So the answer of the limit exists and the answer is 0. If you pass these two tests, like 90%, it's a continuous function, but let's see, because there's a chance of a 10% that this question is tricking you and still the last step will not work. The value that f of x approaches from each side of c, from each side of 5, is f of c, is f of 5. That means what? Step 1 and 2 are equal to each other or no? This is the question. In step 1, f of c was equal to 5, right? In step f of c was equal to 0. In step 2, the limit as I approach c from either side was equal to 0. If this is equal to this is what step 3 says. If these two are equal to each other, then here what did they say? Then it's a continuous function. This is the last test. If the limit as x approaches c of f of x, which is 0, is equal to f of c, which is f of 5 in our case. If they are equal to each other, then I pass the 3 tests, and yes, this function is continuous. If this function that you have failed any one of them, failed this or this or this, then you will write a discontinuous function and you will have probably to mention which type of discontinuous function is this. In this example, we want to identify a point of continuity. Determine whether f of x equals 1 over 2x plus 1 is continuous at x equals to half. So this is our C. Is it continuous at x equals to half? Justify using the continuity test. I know in one step you can just substitute half over here and you will know that there's no problem. 2 times half is 1 and 1 plus 1 is 2. So the answer is half. As long as it's defined and you're going to get an answer, the function is continuous. But what are the tests that you will have to prove with it that it's continuous? The first step, check the 3 conditions in the continuity test. First question, does f of c exist? Does f of half exist? Yes, when I substitute f of half, I'm going to get f of half is equal to half, as we just did. So the function is defined at x equals to half. What is the second question that we ask ourselves for the continuity test? The second question is about the limit, right? So, does the limit as x approaches half of f of x exist? This is our f of x, it's there. What are we going to do? We are going to use a table. Construct a table that shows the values of f of x approaching the values of f of x approaching from the left and from the right. From the left and from the right of what? From the left and from the right of our c, which is 0.5. 0.5 itself, we know its answer is 0.5. This is not my point. I know khalas from the first step that it's defined and the answer is 0.5. So we're going to choose numbers directly less than 0.5 like 0.499, 0.499 and 0.49. The answers as I try to approach this C, the answers look that the C of course is the X. Looks like they're getting smaller and smaller and trying to approach 0.5. So the answer from the left side is 0.5. Find numbers greater than 0.5, for example, 0.5001, we try to be as close as possible, 0.501 and 0.51. The answers are 0.495 and 0.4995 and 0.5. So as I come closer and closer to this C from the left side, from the right side, I'm sorry, looks like the L is trying to approach, or the Y is trying to approach 0.5. So what do you think? The limit exists or no? Yes, we say the limit exists if the left side is equal to the right side. If the numbers on the left of this half are trying to approach the same number as the numbers at the right side. So here it says the pattern of the output suggests that the value of x gets close from the left side and from the right side. F of x, as they get closer to half from the left and from the right, f of x get closer to half, so estimate that the limit as x approaches half of f of x, our f of x is this one, is equal to half. I'm still left with the last question that I will ask myself. Does the limit as x approaches half equal to half? What is this half? Half is f of c, which I found in the first step. F of half, not the x itself. F of c was equal to half, right? Oh, f of half was equal to half in my first step. Okay, so the limit, yes, the limit was equal to half and f of c was equal to half. So they are, I know it's confusing too much halves here, but you know that the answer of f of half itself was half, okay? So if step 1 and step 2 are equal to each other, this proves to us that it is a continuous function. What did they say here? Because the limit as x approaches half of 1 over 2x plus 1 is estimated to be half, and f of half equals half, we conclude that f of x is continuous at x equals to half. The graph of f of x below supports this conclusion, and here the graph, they graphed it for you. Yes, this function is discontinuous, but not at half. At half, it's continuous, and there is an answer, and there is a limit, and the answer is equal to the limit. So I will say this function is continuous at x equals to half.